This example is on the laws of indices. So the laws of indices are given to you in the log tables. If you open up the log tables on page 21, you can see all of the laws of indices on the left-hand side. You'll also see there's laws of logs here, but we'll talk about those at a later time. Okay, like if you're multiplying the two of these two numbers to the same power, you can add the powers together. Here, if you're dividing the same number to a particular power, you take the powers away from each other. If there's an additional power on the outside of this one here, you multiply the two powers by each other. Anything to the power of 0 is equal to 1. If something is to a negative power, it's actually 1 over the positive power. If it's going to be a to the power of 1 over q, it's equal to q root a, and you'll see that one in a second. And then there's a few additional ones at the bottom which we may well use as well. Okay, we'll signal to them when we're actually using them. So the first one here we're going to use is part 1. What we have to try to do here is to simplify or evaluate each of the following, so get the actual answer in the end. 27 to the power of a third. So 27 to the power of a third, we can also write that as the cube root of 27, using one of my laws of indices. And then the cube root of 27 we know is 3, since 3 cubed gives you 27. Part 2, 36 to the power of 3 over 2. Now, using one of my laws of indices at the bottom, if something is to the power of p over q, the p goes in the inside and then the q goes to the outside. So it is in fact going to be equal to the square root of 36 cubed. Now the square root of 36 cubed we know is equal to 216. Now it doesn't make a difference whether I write it as the square root of 36 cubed, or I could write it as the square root of 36 cubed on the outside. Both answers would give me the same thing anyway. That doesn't make a difference. On to part 3. Now part 3 this time we have a minus in it. Now, so straight away we're going to deal with that first of all. So 64 to the power of minus 2 over 3. So dealing with that first of all, it's going to be 1 over 64 to the power of 2 over 3. Then the next part we're going to simplify is the middle. Now using the same kind of logic for this one here, it's going to be equal to 1 over the cube root of 64 squared. Now the cube root of 64 is 4, and then squaring 4, it's going to be 1 over 16. And then for part 4, we have 27 over 125 to the power of minus 2 over 3. So what the minus would do here is it'll end up being 1 over, so it's 27 over 125 to the power of minus 2 over 3. We could rearrange that to be 1 over 27 over 125 to the power of 2/3, or we could even write that as 125 over 27 to the power of 2/3. They would both be the same thing. Now it's up to yourself whether you want to continue on using this one or this one. I'm going to continue on with this one here on the right hand side. Now what we would actually do for this here now is we would have to get the cube root of 125 over 27, and then we would square the answers for both of them. Okay, in order to square the answers for both of them, we need to figure out what the cube roots are. Cube root of 5, or the cube root of this is going to be 5, and the cube root of the bottom is going to be 3. Then we need to square the both of them, so it's ended up going to be 25 over 9. On to the second example. Now looking at the second example, it looks quite complicated. We're going to look at part 1 first of all, and then we're going to look at part 2. We try to simplify the following. Now in order to simplify the following, we're going to add our lines together. Now in order to add our lines together, we are going to use one of the beginning laws of logs, which we have here. x to the or a to the power of p over a to the power of q, you take the powers away from each other. So looking at this first example where we've got x squared y to the power of minus 3 all over x to the power of minus 4 y to the power of 5 to the power of a half. Going to work on the inside part first of all. Now in order to work on the inside part, we can try to simplify the fraction by taking the powers away from each other. So it's going to be x to the power of 2 take away minus 4, and if we're taking minus by a minus is a plus, so it's going to be x to the power of 6. Then for this one we have y to the power of minus 3 minus the power of 5. So you're taking the two powers away from each other, so it's going to end up being y to the power of minus 8. And then finally all of that is to the power of a half. Now if all of that is to the power of a half, we can make both of them individually equal to the power of a half. So it's going to be x to the power of 6 by the power of a half, and then times by y to the power of minus 8 to the power of a half. And then what we can do is multiply the power of the half into each one individually. If we multiply it into each one individually, it'll be x to the power of 3 and y to the power of minus 4. And if we wanted to go one step further at the end, we could write that as x to the power of 3 over y to the power of 4, using the law about the minus power. Second part of the question is square root of a cubed over the fourth root of a times by cube root of a squared. Now to simplify all of this one, it's best if we change them all into powers. So this one here, we can write it as a to the power of 3 over 2. This one here, we can write it as a to the power of a quarter. This one here, we can write it as a to the power of 2 over 3. Now, if we're multiplying these by each other, we need to add the powers together. So the first top part stays the same, a to the power of 3 over 2. The bottom part, using the very first law of logs, law of indices, we can add the powers together. To add the powers together here, it's going to be a to the power of 11 over 12. And then the final part is to take the power away from each other by using the second law. So it's going to be a to the power of 3 over 2 minus 11 over 12. So that would be a to the power of 7 over 12. Now those two particular examples are considerably difficult. Okay, looking at example 3, we need to try to show that the left-hand side here is equal to the right-hand side. Now in order to be able to show that, we need to break it all down. Okay, we're going to work on each part individually. The left-hand side first of all. We're going to try to simplify this bit here. Now we're going to go backwards. Instead of writing it 5 to the power of n plus 1, we can write it as 5 to the power of n by 5 to the power of 1. And then that's minus 4.5 to the power of n. And then that is all over 5 to the power of n by 5 to the power of minus 2 plus 5 to the power of n. And then that is equal to 25 over 26. To go one step further for this one, we can rearrange this one here first of all. And we can even rearrange the top. If we have 5 by 5 to the power of n minus 4 by 5 to the power of n, and that is all over 5 to the power of n over 5 over 25, since this is 5 squared, 1 over 5 squared, plus 5 to the power of n, and that is equal to 25 over 26. Top part can simplify nice and easily here. If we've got 5 to the power of n's, and we take away 4 5 to the power of n's, we're left with just 1 5 to the power of n. The bottom part simplifies. We can use our lowest common denominator here to simplify this full bottom part, and then we can write it as 26 by 5 to the power of n over 25. And then from that, we can use our laws of fractions. So we know that that divided by 26, 5 to the power of n, over 25, we flip the second fraction and we multiply. So it's going to be 25 over 26 by 5n, and then that is equal to 25 over 26, which we had to show originally. Now again, that one there is a very difficult example. You have to go through a considerable number of steps to be able to show that the full thing is equal to this part on the right hand side.